Hello and welcome to the next video for us making Pong. So where we got to last time was we had all of our sounds happening. We've got the game is playable by each player. We're able to be detecting the wind conditions there, so we can hear our bits of sound happening. So we've got that being able to restart, replay the game. Those elements are all happening there now. So what we want to then do next is if we go to our task list here. So in terms of the key remaining things, we've got our AI for the paddles. We've got setting up our settings and our credits screen. So let's start with this. So our paddle controller, this is where I'm going to set this up. And there's a lot of different ways that I could set this up. And in particular, I'll sort of talk through my thought process here with this. What I want to be able to do is I want it so that I can set it up with a basic version of AI, and then we can customize that AI later on. And that it's something that rather than just setting up one very specific tailored AI, we set up a little bit of a framework for being able to do this. So what I am thinking for this is I'm going to create a new folder for AI. And then I'm going to, here in the paddle controller, going to set up a serialized field is AI controlled. So I just want this to be something that I can apply to any of the paddles. And what I'm thinking is I will set up a structure in terms of there'll be a base AI class. So I think if I have a paddle AI base, and then I have we'll call this paddle AI simple. And so what I'll do is paddle AI simple is going to inherit from, actually it doesn't need to inherit. This might be a good scenario actually for using an interface because there's not really much in the way of data that I'm needing to store that would be common, but there are particular functions that I'm wanting to have there. So I think actually I'm going to rename this to paddle AI. So general convention with interfaces is that the name starts with I. So an interface is a way of defining what functions something has to implement. So for example, if we look at our paddle controller, and what we want with our AI is we want it to be able to essentially plug in, and it can provide these input move values. That's what we want it to do, is that it plugs in for providing that particular value. So it's going to be public float. Actually, I don't think I need to make that public. Find out. I'm pretty sure with interfaces, I don't need to have that public. So calculate paddle velocity. And I think, yeah, so I don't need that to be public. Just need that. And then what I do in my paddle AI simple here is I say I paddle AI. And this should be happy with this. I just need to go back to Unity, make sure it gets everything recompiled. And then this is what happens with interfaces. Because I haven't implemented that, I need to actually implement this interface. So that means I need to have public. I'm just going to have this return 0. Because then how this can fit in is I can set up, you can use interfaces as a variable type. So paddle AI, And then what I would do is in start is paddle AI is equal to get component. And I can get it based upon that interface. So I've now got my paddle out. So in C#, we can't inherit from multiple classes. So languages like C++ do allow us to inherit from multiple classes. But with C# we can't. But its middle ground that it provides for that is this idea of interfaces. So an interface can't hold data, but it does allow you to define functions that need to exist. So in this case, paddle AI simple inherits from mono behavior, but implements iPaddle AI. So handy sort of little setup there for it. So then what we would do is if something is AI controlled, so F is AI controlled, so the AI is providing the input. So I think how I would want to do this. So there's a few different ways that I could do this. I could have it that the AI is providing that actual input move with inertia value, or the input move one. But I think the best thing is if I have it that the AI is effectively applying the same kinds of controller inputs that a player can. So if we're not AI controlled, then we retrieve that input. Otherwise, if we are AI controlled, then what we would do is we would say our input move is equal to our paddle AI calculate paddle velocity. So this means that if it's AI controlled, we are just bypassing the movement input. And by providing that movement input, this opens up actually a range of techniques there in terms of if we wanted to, we could do stuff that is trying to actually, we could train things like some machine learning based AIs. You could train a neural network based on, well, here's the input for the ball in terms of the ball location. Here's what the player's input is, and you could compare that to what the neural network calculates. So you've got a feedback loop there, in that you could have that essentially training a neural network to mimic how a particular human player is playing. You could do other techniques there in terms of reinforcement learning ones, where based upon whether it scores goals, stuff like that. So I think this gives us the most flexibility. So this input here, and just to force the AI to have to be honest, we're going to make sure that this input is clamped between -1 and 1. So even if the AI decides to cheat, the actual paddle logic is going to be nope and prevent it. So okay, that gives us a setup there for it. And what I'll do is each paddle, I'm going to attach the AI onto it. Because the benefit with this structure is I've set it up so that I can easily use multiple, any paddle can become AI controlled, which is handy, really good for testing. And also the AI might do a better job of playing than I do. It's a good chance of it. Okay, so they're both AI controlled. Which means at the moment, I can test this. Any keyboard input should be ignored, and then so we've got no keyboard input. The paddles don't move, which is good. So now we can look at how we want to design this AI. So one of the things it's going to need is it is going to need to be able to access that ball location. I'm a big believer with AI in terms of design philosophy, and in particular my design philosophy with AI. I try to design AI thinking about what would I do? What would a player do in a particular scenario? And then trying to have the AI do something like that. And then try and think of edge cases. And the goal for me with AI is always that anything the player does, that the AI should react to. that any stimulus the AI receives gets a response. Not that that response is necessarily effective. That's a key thing with this. I don't believe that every response necessarily should be effective. The AI can make mistakes. The AI can be, have a poor response to something. That's okay. The key thing is that whatever actions the player takes, that the AI acknowledges them and responds in some way. That tends to feel better to players. It feels like the AI is reacting directly to them and what they're doing. So it's really sort of key aspect, in my opinion, with sort of building AI. So I don't like AI that sort of cheats. I want the AI to be ideally not cheating at all. So I'm only going to give the what I'm going to do is set up a ability to active ball to retrieve the active ball, and that is all I want the AI to have access to. So it's got to do its calculations based upon that. So I think this is a simple one. So what we could try and do is essentially something where it is following, and it's trying to always position so that it is next to, or it's in line with where the ball is, so it's sort of chasing it. And this is the thing, we've got different approaches with designing AI. We could design something that plays very defensively, or we could design something that plays offensively, or we could design something that's doing a mix of both, or that chooses when it applies particular strategies. So there's different ways that we can have the AI behave and convey different personalities to it. So I think what I can do is if I go game manager instance, active ball. So I want to get its position. And in particular, I want to get its Y value. No, not its Y value. If I check my axes, I think it is my Z axis. Pretty sure that's what yes, it's the Z axis that things move on. So I want to get its Z relative to my Z. So this is the delta Z. So ball delta Z. So I can see how far away it is and which direction. Because a delta Z that is a positive value should indicate that we need to move up. A delta Z that is a negative value should indicate that we need to move down. And then I think what we could do with this is serialize field. And I think we have a slew rate, so how rapidly it tries to change to that new delta value. So the maximum input values are going to be 1. So if we set the slew rate as like 1, that would mean it would take 1 second to fully react. I reckon we can make it probably, if we say like 5 seconds, because then I think here we retrieve this, and then we can adjust our inputs, I think. And so what we could do is target velocity is equal to 0. So we continually calculate this in update, and then so our actual calculate paddle velocity is just going to return that. And then I think we slew this based upon our delta Z, which what I reckon, we have something here where, so a max position delta, so the maximum distance that the ball can be away from the center point. And what this will determine is when the ball is more than this away from our center point, that's when we want to do our full input. So I reckon if the ball's more than maybe, let's try 2 meters. Because what I would do then is going to keep the delta z like that. And I reckon for the correction, if I use something like an animation curve, my thinking here is an animation curve. So I know my delta z, I know the maximum position it'll give full input, so I can normalize that delta. And then based upon that animation curve, I can control how strong the reaction is based upon that how far towards that delta value it is, I reckon. I feel like that might actually need to be 1. So my animation curve, this is going to be my velocity output. So what I would do is velocity output, and I'm evaluating. So I want to evaluate the MathF absolute of all delta z divided by max position delta. So that's going to give me something that is always going to be positive, and it will go from 0 to, it could go over 1. So I would do a MathF clamp 0, 1. So this is giving me and I might pull this out just for clarity, normalized ball delta z. This is giving me one that is going to always be between 0 and 1. And then regardless of whether that correction is positive or negative, it's going to tell me how far away that is. So that's then something that I can feed into here so that my target velocity is now my normalized ball delta z fed through the animation curve multiplied by, because I need to bring that sign back because I need to know whether it's moving it up or down. So I can use MathF Sign and get the sign of that original variable. Calculate the position delta of the ball relative to us. Calculate our target velocity. Now we wanted that slew rate, so we want to target velocity won't be the actual when we return. Current velocity will be the one that we return. Now we might have the case where we have no active ball. So if game manager instance active ball is equal to null, then current is equal to target is equal to 0. Just in case, there is a chance that we could have no actual ball active. So we've got our target velocity, and then we've got our slew rate, which is going to control how rapidly we move towards that. So our current velocity is MathF move towards current target slew rate by time dot delta time. This just allows us to, so we're working out how strong a correction. The slew rate allows us to apply a bit of a delaying factor on that to give the AI effectively a bit of a reaction time so that it's not too just overpowered. Slew the current velocity. There we go. So I feel like that should work pretty well. I'm going to need to set up the velocity output. That one, I think let's just start with ye olde S-curve. Usually is a pretty good starting point. So this should give us AI versus AI. And I'm kind of interested to see how this plays. Can I make an AI that plays better than I can? Quite likely. Whoa. So that's, an interesting thing there. We can see that it is, at times it can make mistakes, and it probably needs to, because one of the things that does mess it up, we can see there, is all of that bouncing, which we could have it that how much it tries to move is a little bit based upon how far away it is from us. So there's things we could do there with that to control it. But I'm pretty happy with how that works. It makes mistakes. Does a better job of playing than I do, which I think is highly amusing. So yeah, we could absolutely factor in things like the speed the ball is going at. Would be something that we would be able to factor in there, and potentially do a stronger reaction if the ball is moving faster. So I might put in that just as a slight additional thing. So this is where the ball is going to need normalized velocity. So that will be current velocity magnitude divided by maximum speed. And so that should be a 0 to 1 value, but just for consistency, I'm going to clamp it. Because what we could do then is, in our simple AI here, the strength of reaction that it's trying to do, that could actually push this delta Z up. So what we could be doing there is serialized field, and I kind of want to run this through another animation curve. Ball speed modifier. Because this will give us something where what I would do then is I would actually run normalized, this I would run our game manager instance, active ball, normalized velocity. So ball speed modifier. So there's different ways that I could apply this. So this is going to get the ball speed, actually modify based on ball speed. So what I could do, there's different ways of how I could apply this. I'm actually thinking I apply it down here in the target velocity. That what I do is I say target velocity multiplied by 1 plus the ball speed modifier. What that will mean is, if we then take a look at how we set this up, so that means, and I'll set it up for, I'll make paddle 2 have this, have a particular one of it. So if I set this to be, say, linear, what that would mean is when the ball speed is quite low, that we're making no change to that target output value. But at a very high speed, we would be doubling our output. So we're doing a large increase there for it. And I feel like linear is probably going to work pretty well. But let's actually make one linear and one an S-curve. So AI1, player 1 is going to be S-curve, whereas 2 is going to be linear. Let's just see how these play out, if we see much of a noticeable difference. In theory, what this should mean is that when the ball's faster, it's able to correct a bit better. And I'd be interested to see whether we notice a better job being corrected by 1 or 2. They do seem to be a little bit better at reacting. Some cases like of that. And so part of this is because it doesn't, the paddle is trying to position its center point. So that's something where we could be changing that, and it's not necessarily trying to position its center point, but it's trying to position any location. Paddle 2 definitely seemed to be doing better there. But let's run it again and see if that's consistent, if that holds. Should be interested to see if that does. That first point was kind of a freebie. It definitely didn't react as rapidly there as it could have. But that's I'm pretty happy with that. And we've got a decent framework for correcting it. And so, yeah, I would say the two paddles, you do at times, because they both track the ball. And that could be something where we only track the ball when it's in our half of the actual playing field, could be a thing as well. And having it that when it's in the other half, we return to 0. So there's strategy aspects that we could be applying there with this in terms of how the paddles choose to behave. So we could do things like of that, in that the AI would need to know which side it is on. So we would need to have something like what we could do here is we could say ball is on left side. And then what we could say is, okay, and this is where we start to get a little bit more sophisticated. What I would probably do is, well, is ball on our side? So in this case, we could say F is on left side. So if we're the left side AI, and game manager instance active ball transform position X. So left side is to the left of 0. So if it's less than 0, then we return true. Otherwise, if the game manager instance active ball transform position X is greater than 0, then we return true. Otherwise, we return false. And again, we might have no active ball. So active ball is not equal to null. So we've just got a way of checking if it's on, if we are on, well, the ball is actually on our particular side. Because then what we could do is, okay, F is ball on our side. I might split this out to void update move towards ball. I'm just going to move all of this part down, because the current velocity slewing I think is fine. So if the ball is on our side, then we do update move towards ball. Otherwise, what we'll do is an update move towards center. So we recenter the paddle. Void update move towards center. So we're able to actually use a fairly similar set of stuff here, in that what we can be looking at is, well, the delta Z is actually going to be our transform position dot Z. And so that we want to bring that towards 0. So what I can do, and we can get rid of, we won't need the velocity set up here. Actually, no, we do want that velocity set up. We don't want this modification stage. So our target velocity, so whatever our transform position z is, we actually want it to be the opposite of that. So paddle delta z is minus, because if we are at minus z, we want to make a correction to 0, which means we need to move in a positive direction. If we're at a positive z value, then we need to move in the negative direction. So position of the paddle relative to the center. So this is our normalized paddle. And again, we can keep that same max position delta. And we just use our sign value there. So this should mean that if we tick the correct boxes here, the paddle will return to the center. So that should mean a bit of a better performance there. And I'm going to, the ball speed modifier was linear with that one and an S curve. So I'm going to change both of them to be the same. So paddle 1 is set to be on the left side. So let's give this a go and see how this behaves, because we should get different behaviors then now. So this paddle's not moving until it's over its side. And that definitely does make a noticeable change. Now, maybe with that, we want a bit of a buffer. Maybe we want it to be checking a little bit of a buffer there. On site, actually, you could have reaction distance. That's another way that we could look at doing this, is having it that we have a distance that we react at, because we know our paddles are at 7 away from the center. So we could actually say, well, the reaction distance is 10. So then that changes our behavior here, because what we're doing is we'll return if MathF ABS ball's position x minus our position x is less than or equal to reaction distance. So now we're encoding a distance that we react at. So again, different ways that we could go about approaching this. We could adjust that based upon speed. So you could actually have a reaction time that it starts to react when it thinks it's within a certain time frame of it. And now we should see that the paddles are tracking now a little bit better again, in that they start reacting a bit sooner. And that's pretty good. I'm pretty happy with that. Like, their reaction is fairly solid, and they are returning back to the center, which I think is good. That also means that at the end of a game after a point's scored, they're returning. And we could also, there's a lot of changes we could make and tweaks that we could add to this. But I'm pretty happy with that. Now we need to have some stuff communicating through to this so it knows that it's actually starting in AI mode. So this is something where the game manager, I think, is best placed to be doing this. So I think what I would do here is serialize field, paddle, controller. So I want to give it both paddles, so it's got access to those. And right. Then what I'm going to do for just carrying the information over is there are lots of different ways that I could approach this. It's a fairly simple setup that we've got. So I'm actually going to use player prefs for this. And what I'm going to do is I'm just going to create a new script here, a new folder for the script first. Settings. So player ref keys. just as a nice way of being able to actually easily store these, because what I want to have to sort of be class, and this will have a public const string game mode, and this will just be game mode. So what I would do then here is in the game manager, okay, well, if player prefs dot get, and I would use a get int, because then I can say player ref keys dot game mode. Actually, use human versus human might be what I actually put this as. So game mode dot human versus human. So f getting that int, and I will default it to 1. So the default is that it's human versus human. So if that's the case, then I want to say, well, left paddle set is AI controlled to false. Do the same with the right paddle. Otherwise, what I will do is the left one will be human controlled and the right one will not be. This just means then I have an interface that this is going through. So here, public void, and then rule is AI controlled, and I can then just set that variable. So what did I call it? Oops, not in the ball. Let's go into the paddle. So in our paddle controller, and I think I'll set it up down here. So in this one, and you use AI controlled, so I'll just set that. We've got the ability to then set those particular values. So I can close all of these. Game Manager is checking that, which is good. I can go back to my main menu. And remember, we had this set up here. So what I would be doing is player prefs set int player pref keys is human versus human to 1. And there are other ways of doing this. This is just, it's such simple data, we can just go for a really low-tech way of doing this. And this should mean, if I then go back to my main menu scene, that if I pick human versus human, I should have it be fully controllable. So human versus human. And so that's something where, if we take a look, I forgot to link up the paddles. That one is just, it's one of those things that no matter how long you've been working on stuff for, it's one of those errors that you just are always going to run into. So it's just easiest to accept it. Okay, let's try that again. So we're running pick human versus human. We've got full control, which is good. Let's try then with playing it and be human versus AI. And what we should expect is we can control the left paddle, but we cannot control the right paddle. So I'm trying to move it, I can't. And if my own AI manages to beat me, does that technically mean I still won? It's a question for the ages. So there, we've got our AI up and running. So that's pretty good. I'm happy with that. So Paddle AI, and we've got that set up in a way that if you want to experiment with this, if you want to try adding in extra things, you can. So go for it. Try adding in extra cool bits and pieces there for it. So let's look at other bits that we want to have up and running. Well, we wanted to, with our menu here, have some extra stuff in terms of having settings and things like that, and I think that would be a good thing to set up. So I'm going to put extra buttons here. I'm going to duplicate that spacer and put that there. So we're going to have credits, going to have settings, move the connection for those at the moment, same with settings, can remove that, and then update our text. I might change the order of these. I think settings above credits looks better. There we go. So we've got that up and running. Let's look at getting our menus here set up. Well, let's turn off our main menu and let's turn on credits. So there are things that I would want to just generally bring across. So game title and version, I would want to keep those actually in all of these, because I think that's an important thing to have these in all of them, just as a nice, easy way of keeping a consistency between the screens. So we've got that. That looks good. We know we're going to need a button to go back to the main menu. So let's chuck in a button. It's going to be main menu. Can update the height of that a bit. And what did we use for font size here? Because I think we want to match that same font size for consistency. So 24, just going to fix up the naming of that. So let's make sure we've got this as 24 as well. Yep. Main menu. I might put like that. Yeah, no, I don't think that's necessary. So then we can position this, I think down the bottom right is going to work well. We update our values here. -10. Cool. So that's going to take us back to the main menu. We want that to be in the credits as well. So let's make sure we've got that in both. Excellent. So, okay, we'll have our credits. Credits is going to be one of the easiest ones. We'll have a credits text, and that can be positioned in the center there. We're probably going to need a bit more of a height, but we'll center everything. And let's make it a bit wider, not 4,000. That looks pretty good. So in this case, I'm going to put in me. Key thing when you're setting up credits, make sure that you are crediting any additional sort of assets, resources, things like that you're using. Check those license agreements, see what they require. If they require you to be attributing them, make sure you do that. If your game is able to be monetized in any way, so if there's advertising, if you're selling it at a flat price, if there's in-app purchases, anything that's potentially able to have it be making income, make sure that your licenses allow that. There are some cases where things are okay for attribution if it's free, but then as soon as it's something commercial, you do actually have to have a paid license. So make sure you look into that. So that'll do for our credits one. Now, in terms of transitions between these, I'm going to use, because I really like using them for this, and I think they allow a lot of nice control. I'm actually going to set up timelines for this. So timeline, main menu to credits. We'll also have main menu to settings. We'll have settings to main menu, and then we will also have credits to main menu. So we can just bring all of these in. Let's chuck them under an empty object just to group them neatly. Doesn't really need to be done, but I like to keep the hierarchy neat and tidy where possible. So, okay, let's set up our timeline to go from our main menu to our credits first. So we already set up with our main menu and our settings and credits, them having that canvas group so that we could animate them. And that was intentional. So what we can do is we can select our timeline, and then we can drag our main menu down into here, and it'll be an animation track. And then so what we're going to do for the main menu is we start recording. Then in main menu, we can see we've got our canvas group here, so we can just tweak that initially. And then we want this transition to be pretty rapid. I reckon a second is fairly good. So I think by actually, I think half a second even. I think we want it to be pretty rapid. So at that point, alpha is out. We can turn off interactable. That looks good. So we can then also potentially turn off the main menu at that point, but we have turned off raycasting and things like that, so that's likely going to be enough. Then what we can do is we can drag in this one is our main menu to credits. So we would drag in our credits one. We want an activation track. And here we set at the end of this that it leaves it as active. We want this to happen at about 0.5. So this is going to be a 1 second transition for all of this. Because then we bring our credits in again for an animation track, start recording, and our credits, we say, okay, that alpha is going to start at 0, and our interactable and everything are off. Then at the end, we want the alpha to be 1 and everything to be interactable. You can see those only become interactable at the start. That looks pretty good. I'm happy with that. For all of these timelines, we don't want them to play on awake. That seems solid. For the main menu to credits, we also want to control turning off that main menu. So we can do that as well, adding an activation track that goes to 0.5. And then at the end of that, we say that main menu is inactive. So we're turning our main menu off, fade it out, fade in the new one, make it interactive. So that looks pretty solid. Let's set up our one for going back from that. So we can copy all of these. We can take our credits to main menu and we can paste these in here. And then we're going to do the opposite essentially. And so what we can do is this one where our main menu, we were saying that it was getting left as inactive. Well, it's actually going to be left as active. Let me move this over. Do similar with our credits, where it's actually then getting left as inactive. And what I would do is I would actually record a new animation here for this, or I can actually edit this existing animation. So we can edit it, or if I remove it, then we can go and record another one for it. So you can select this stuff and remove it. Then so we're animating the credits first going away. So I'm going to bring this animation one down here, just so we've got things grouped properly. So what we would do is with the credits first, let's animate that. So the credits is starting at a value of 1, and starting with these is interactable. And then at our 0.5, this is now 0 and no longer interactive. That looks good. You can see straight away it's going off. And I'll probably actually have to turn these off straight away. So that looks good. And then I would, for the main menu, at 0.5, what we want to do is with our main menu, it's now active. Alpha is starting at 0, and it's starting with things not interactive. And then it goes to 1. And that should be pretty good. So let's test this out. We know our main menu is going to be starting with that on and everything. So let's test out going to our credits and then back. We want to make sure that that works reliably. So we hit credits. Now we don't have it hooked up, so let's link this up. So credits links to main menu to credits, playable director, play, and then the one in credits here, we link that up to go from credits to main menu, playable director, play. Excellent. Let's see how this goes. Here, go to credits, fades out, goes back. Got that working nicely, so that's good. We can then set up a similar thing with our settings one. So settings, let's just link up the playable director now. Playable director, play. And then same thing with the settings button here, that we can then just say that that is going to play the settings to main menu one. Play. Excellent. So let's rig up our settings timelines then, just so we've got them up and running and we know that they are working. So we can actually, again, copy. So our credits to main menu is going to be very similar for our settings to main menu. The main difference is that rather than talking to credits, that's going to talk to settings. And that here, we remove these curves. We link this over to the settings one, let it create the animator. So this is going from our settings to the main menu, so we can record this, and what it will be doing is, we know the alpha is starting at 1, turn off things being interactive, at 0.5, leave them off, alpha is 0. So that should give us our one that will go from settings back to the main menu. And then we can do a similar thing here, because we've already got these largely sort of set up. And I'm going to reorder this so it's a bit nicer. This is the advantage, because they're very similar, we can actually just duplicate the sections and there's not too much in the way of updating that we're needing to be doing. Because this one ends up again talking to credits, was talking to settings instead of credits. Again, we can remove those curves and record the animation that at this point for the settings is going to, it's not going to be interactable, its alpha is going to be 0, but by the end, it's all turned on. So that should mean we now have our transitions between all of those, which is good. So we've got it that we can be going to settings, and go back, can go to our credits. Excellent. So let's put some stuff in our settings menu now that we've actually got this. Can rig this up. So there's not going to be too much we need in the way of settings. And because we've only got, in terms of the audio settings, it's only audio that we've got. So I'm going to have this just centered, I think. Yeah, I think centered will work. I think 600? That feels about right. So we don't actually need too much in the way of audio settings because we only really have sound effects group. If we go to our mixer, we have our sound effects and background music. We don't have background music set up, but let's put in the hooks from the UI point of view for making this work anyway. There's no reason for us not to. It's quite quick to get set up. So we're going to need some text. We're going to need a slider. I'm going to put in both of these. So what we're going to have is sound effect volume label, sound effect volume. And if we remember, with working with mixers, these go from -80 to 20 from memory. Yes, that's what they go from. So then we set those just as our ranges for that. We've got our music volume label and music volume. And again, we'll set that so that it goes from -80 to 20. Can just be whole numbers. We don't need, I think, more precision than that. That looks pretty good. Sound effect volume 100%. So I think we can list it like that. Music volume. That looks pretty good. Let's lay these out with a vertical layout group. I think will be good for just spacing them out. We're not going to force expand in height, but I do want to make these sliders larger. Because 20 is a bit small. I feel like 50 works a bit better there. Let's put in some padding here so they're not all really tightly constrained like that. That looks pretty good. I could again do the thing of, if I wanted some spacing, I could do a UI panel there. I don't think I need to though. Got that. That looks pretty good. I want to make these sliders look a little better. So that handle, we can look at different sort of sprites for that, which I think that looks a bit of a better sprite for that. That looks good. Excellent. So let's set up our script for settings, because this is going to need to interface with these to change the values. And actually, I might change the name of that. I don't think settings is actually an ideal one, and I want to put this under main menu anyway. So we'll rename it to settings menu. Settings menu UI. I think that's a better naming for it. So if we remember, with the volumes, we need to expose the attenuation here and then rename that. So SFX volume, expose the background music one, BGM volume, good. So we've got those accessible now in our main menu. Well, for the settings, we know we're going to need a couple of ones here for the usings, because we're going to need to be able to access the Unity UI stuff in TextMesh Pro. So I want to be able to access the labels because I want to update the text of those. SFX label, SFX volume label. I also want to have a one for music volume label. And I'm going to have my sliders. Slider, SFX volume. Going to need the slider for music volume. And I'm also going to need my audio mixer. So I need to bring in using Unity Engine audio. So I want my audio mixer. Target mixer. And then I know from a input point of view, I'm going to have a on SFX volume changed. It's going to give me a new volume value. I know I'm also going to have a on music volume changed. So when I receive these, I need to tell the mixer. So I need to say, hey, target mixer, set float. I need to tell it SFX volume and the new value. So that's the first thing I need to be doing. Also need to update my text because I wanted to have that nice sort of text display there. So SFX volume label text is equal to sound, so what was the naming I used? Sound effect volume. Volume plus new volume to string plus that. And I think what I want to do with this, so this volume is going to be minus 80 to 20. So what I could do is if I actually, yeah, I'll normalize that. Normalized volume is equal to new volume minus SFX volume dot min divided by SFX volume max minus SFX. This way then it's just always, I can reliably say that it will be between that 0 and 1 value. So I can make this then normalized volume multiplied by 100. And I could round that to an int. So I don't even need to worry about doing extra stuff with the conversions there. So that looks pretty solid. Normal, and that's going to work quite nicely. Can do a similar thing here. Changing the background music volume. I need to make sure I talk to the correct slider. And again, this is the thing, copy and paste is fine, but you need to be really careful to make sure you change the right stuff. So that will work. That should mean that we've got these able to be behaving the way we need. So I can link up my settings menu UI. I can link up my different labels here that I need to, and the different sort of sliders. So I've got everything connected up. And then I can link in the mixer. So that's good. I need to make sure I set the initial values here, because that's the other thing there is I want to actually, from that mixer, update those sliders. So I would have something like SFX volume value, which I'm not using the without notify one, because I actually want it to run the code here, because then it will go and change the text for the labels. So I can say target mixer get float SFX volume That's right, it uses out values. F target mixer out. So float volume out volume. Then what we would do is our SFX volume value is equal to volume. And then I would do a similar thing for the music. Background music volume. So that's good. Let's take a look then and see how this behaves. So we turn off settings now. We want to have it that we actually have to directly go to it. So again, we're making sure we're testing the paths that we've set up with the UI. So we go to settings. So that looks like it hasn't properly, and that's because I didn't link up the sliders. Always an easy thing to forget is linking these up for when the value has changed. So that's why always testing. It's just as soon as you're doing little bits of stuff, just always make sure you go back and test. It's really super easy to miss stuff like of this. And we just want to make sure we catch everything. So we go to settings. So now when I update those, that's changing. It doesn't actually change it initially, which is interesting. And I forgot to put in the percentages here. So this is interesting that that's not actually changing because it should be running the actual notify logic, which is unusual. I'm just going to put in a breakpoint or two just so I can test and make sure that it is actually running that. Because I definitely want it to be. Run, go to, I know what it is. It's because potentially that value is exactly the same as the volume value. It is, which means it won't trigger a notify because the value technically has not changed. So what I would be, a way to work around that is a couple of options. One option would be to bring over the code from here. That's probably one of the easiest ways of doing this, or I could actually call the function manually. So I could do on SFX volume changed, SFX volume value, and on music volume changed, music volume value. So it's just going to force the logic to be invoked. Refresh the UI. Force refresh the UI. Retrieve the volumes. That works. Let's test how this is going to behave. So we are up and running. Should mean that when we go to settings, it is going to be at 80%, so that's good. Now, one thing we'll notice is it doesn't actually remember those settings. It does when we go back into here, which is great, but not when we close and restart the game. So that's where we can add in some final little extra bits into our player pref keys. Let's have a const string SFX volume, audio SFX volume, and another one, audio TM volume, which is good. Because then in here, when we go and change these, what we would be doing is we would then be able to say player prefs set int player pref keys dot sfx volume, And we are setting that to new volume, which we could actually use set float for that. That's fine. We do the same thing here, where we set this BGM, and then we save it. Now, this does mean it's doing it every single time we're changing it. And that is something where there is a slim potential for there being performance issues with it. This is definitely not the most efficient way. But when we're focusing on setting stuff up, efficiency is not something that you want to prioritize too early on, because efficient code is usually less maintainable, it's usually harder to read, things like that. This is something where, yes, this is not going to be amazing performance, but is it likely to be at a level where it is going to have even a remote chance of causing issues? No. So we don't need to worry about it. So that looks pretty good. That will save the values. Now we need to make sure we're loading them back up at some point. Now we can't do that in start here. And the reason is that this game object is not active to begin with. So because it's not active to begin with, it means that its start doesn't run until we go into that menu. It means if you never went into the settings menu, you've never actually grabbed the audio. So what I would probably do in a case like that is my actual main menu. Now, on a larger project, I'd have sort of something that sits in the background in like a second, like a bootstrap scene that gets loaded and does this. I think for something simple like this, it's completely fine for us to bootstrap off of something that we've already got there. So Unity Engine Audio, Audio Mixer, Target Mixer. And then what I would have is I would be saying, well, Target Mixer, set float, SFX volume, and I would do player prefs get float, player pref keys dot SFX volume, and then put the default value, which is just 0, and do the same thing for BGM volume. And this is something where, okay, I reckon I'm going to set up a new file, audio mixer keys. So I don't really like using a lot of hard-coded strings like that. So I don't think it's not good practice. So I want to get rid of those. So what I can do is in here, I can say audio mixer keys, SFX volume, and it'll be audio mixer keys. Music volume. I'm going to bring these over to the other one as well, the settings, just so that I don't need to be doing these extra bits where I've got strings where I could easily have stuff not match. I want to avoid potential problems like that. And this just means that I can't have that happen because they're all referring to the same thing. So what this should now mean is that when I change my audio volume settings here, that those get remembered. That I can go in and I'll change the settings and then I will stop and restart it, and it will actually have those once I link up my audio mixer. So we'll run this and go to my settings. So let's drop the sound effect volume to 50%. Go back to my main menu, we stop, we relaunch, go to settings, and it's still at 50%. So we have our settings and credits done. We do have our stretch things that we're going to add in, and that's going to be in the final video. We're going to be taking a look at the additional bits we can add in. But we now have a fully playable game that has our main menu, has settings, has credits, has human versus human and human versus AI modes. We've got sounds triggering in. We've got our end game loop activating there. We've got a framework that will allow us to set up different AI behaviors as well. So we've got a complete game that we can now extend and modify and add to. So dive in and experiment with it. Look at things that you could change with the AI. Look at cool ways of setting it up. We've got a really solid framework there for it, where you just need to be outputting a value from -1 to 1. We've got stuff there where we can see how we can track the location of the ball and reacting to stuff. So there's a lot of bits that you can experiment with. So dive in, experiment with it, see the kinds of cool things that you can be doing there. Thanks, folks. If you're looking for the code for the project, then in the description below, you'll find a link to the GitHub. And on the GitHub, I've got the code for this project and for all of the other projects there freely available. And if you have found the video helpful and you'd like to support the channel, then throwing in a like or subscribing is always a huge help. If you're looking for further ways to support, then I do have a Patreon set up, and that's going to help me keep managing to do these videos for a long time to come, which is going to help more people make cool things. And that's awesome, because that's what this is all about, is helping more people make more cool things. And that is all. Thank you.